Hello friends, how are you doing? Alright, welcome to my channel. So in this video we want to look at solving exercises. The truth is that exercises, they are just what you need to build your muscles in maths. If you forget or look away from solving plenty of exercises, you would actually not be doing yourself good in terms of mastery of mathematics. So it's very important, and that's why we're beginning this particular series of solving exercises of topics. And I'm beginning with these. There are 30 exercises of this particular chapter. Is the first part of the exercises. It has some medium questions, some easy, some intermediate, and all of that. So we would like to see how far we'll go with it. Now, it's important to note that this particular video is non-scripted. I didn't go through these exercises before now, so we are going through it together in this particular video. And the essence is so that you will understand that to solve problems, all you need is to just think through and see what you can bring out and then see how to get the solution you need. And then we are beginning with this first example. So it says that we are given that 3 raised to the power of n is equal to 1 over 81, and we are to find the value of n. So what do? Now basically we will try to apply that rule that says that if a is raised to the power of n is equal to a to the power of m, so this only means that our n is equal to m. Okay, so and then of course what do we try to achieve? We try to see how we can write this to be in base 3 so that this rule can be applied. And then of course we know that 81 is 3 to the power of 4, and so if that is true, then it means that 3 raised to the power of n is equal to, then this other side we can write as 3 to the power of minus 4. How did we get that? Because we are also told that if we have a to the power of negative n, that is the same thing as 1 all over a to the power of positive n. And of course we can go the opposite direction, and so that means that our n is equal to negative 4. So that's the solution to the problem number 1. So let's see exercise number 2. Alright, so the second example says that we should simplify 27 to the power of 2 over 3 multiplied by 32 to the power of 2 over 5. Alright, it's important that we note that when it comes to fractional index, there's a rule we call the rule of fractional index. So we can actually apply that here. It says that if a is raised to the power of x over y, then we can write this in such a way that y will become the root of a, and then x, which is the numerator of the fraction, will remain as the power. Okay, so but is that going to be the best option? You can use that approach, and if we do that here, we are going to have 27. So this 3 will now become a cube root, and then everything is raised to the power of 2. Then multiplied by, here we now have 5th root of 32. That's raised to the power of 2, and this is going to give us the cube root of 27 is 3, then to the power of 2, multiplied by the 5th root of 32 is 2, then to the power of 2, and this is going to give us 9 times 2, which is 9 times 4, which is 36. Okay, so meanwhile, from this particular step here, you can actually choose to take another approach of getting the same value. And what is that approach? There is a rule of distribution of powers. So if I have a times b all raised to the power of n, then I can write this as a to the power of n times b to the power of n. This distributivity of power only holds for multiplication and division. So that means if I have a all over b all raised to the power of n, that is the same thing as a to the power of n over b to the power of n. But this is not true for addition and subtraction. So if I have a plus b all to the power of n, it is not equal to a power n plus b power n, and the same applies for subtraction. So I can actually use that approach here, and then in this case, since the powers are already distributed, so I can gather them together into 3 times 2 raised to the power of 2, and 3 times 2 is 6. 6 to the power of 2 will still give me back the 36. Okay, now remember I said that you can actually choose to do from this point in another approach, and that can actually be a little bit more much easier. And what is that? Instead of looking to use a fractional index rule here, I can decide to take 27 into index form. And of course, if I do that, 27 in index form is the same thing as 3 to the power of 3. And there's already an existing power there, which is 2 over 3 multiplied by, I will do the same for 32, and that will give me 2 to the power of 5. And that is to the power of 2 over 5. And then here I will apply a rule that says that if I have a to the power of n all raised to the power of m, that is the same thing as a to the power of n times m. Okay, so we will now try to multiply the 2 powers up here, and of course what will happen here is that 3 will cancel this one, and so we just have 3 to the power of 2 multiplied by 5 will cancel this 5, and you will have 2 to the power of 2, and then you are back to this point, so which will of course give you our 36. So you would like to choose which one is better for you. Okay, so we then go to exercise 3. So there we can choose to open this bracket, the 2 powers will multiply, and that will give us 27 to the power of 2 over 3. Okay, and we already worked on something like that. I think that's what we have here, so which is going to give us 9. Okay, how did we get that 9? I already said that you can write 27 as 3 to the power of 3, and then of course this will multiply, so this will cancel this. You just have 3 to the power of 2, and that's equal to 9. Okay, so let's look at the 4th exercise here. So remember that some of these exercises are looking like repetition of each other. Yeah, the repetition is what brings about the clarity. So the more you repeat, the more you are able to know the best approach to use, and it makes the whole process far easier than the time you did the first example. Okay, so here I can choose to write this in index form or use my fractional index rule. Of course, power half would be a square root to the power of 1, which is the same as square root. Power 1 over 3 is a cube root. Power 1 over 4 is a 4th root, and so on. So, but if I use the approach of reducing this to index form, this will give me 6 to the power of 2, all raised to the power of half. So the 2 will multiply. Then I will have times. Here now I'm going to have 64 in index form can take two different forms. It can, or even 3. It can be 4 to the power of 3. It can be 2 to the power of 6. And it can be 8 to the power of 2. So the question now is, which one of these 3 can I use? And like I said, this is the reason why you solve problems, so you know which one will make your work faster. Any of them can actually help you get a solution, but the first one would help you get something faster. Why? Because the denominator of this external power is 3, and so you can easily cancel out these 3. So and I can have 4 to the power of 3 multiplied by minus 1 over 3. And that's going to give me, these 2 will take away these 2, so I'll just have 6 multiplied by 3 will take away this 3. I will have 4 to the power of minus 1. And of course, this is 6 multiplied by 4 to the power of minus 1 is 1 over 4. And by the time you multiply this, of course, this is 6 over 1. That will give you 6 over 4, which is 3 all over 2. And that is the solution for this. Okay, so to problem 5. So for example, problem 5 here, we are to find the value of y, assuming 3 to the power of y is equal to 243. Okay, so the same thing we did in problem 1. So we'll try to write 243 in base 3, and that's going to give us 3 to the power of 5. Of course, you can check that by doing 3 times 3, and then you keep going. Why are you using 3? Because you're seeing base 3 on your right, on your left. So it's expected that the right should also be in base 3. So except you try it and it doesn't give you that, then you now use other means, which is to take the log of both sides. So here, as I go by 3, this will be 27. By 3, this will be 81. By another 3, I will definitely get 243. Okay, and you are done. Your y here is equal to 5. Okay, so we'll look at problem 6. Okay, so in this one, we are to actually simplify this. Okay, so what is it going to do for us? Here we have division. So the same thing, there is a rule for division that says that a to the power of n divided by a to the power of m is equal to a power n minus m. So I'll try to see, is it possible to write the both numbers in the same base? Yes, I can write 9 as 3 to the power of 2, and the 2 will multiply the existing power. Then divided by 27 is 3 to the power of 3, which will also multiply the existing power. So what happens next? Okay, 2 here will cancel out 2. So I just have 3 to the power of minus 1 divided by, then in this case, 3 will cancel 3. So I just have 3 to the power of 2. And that will give me, so this will be equal to 3 to the power of minus 3. You can stop here. That's leaving your answer in index form. Or you can write it as 1 all over 3 to the power of 3, which is 27. So either ways, your answer is correct. Okay, so let's look at problem 7. All right, so for problem 7 here, we have a combination of multiplication and division. So and what is that going to be? The same way, try to simplify what you've got. So if we do that here, we already have 3 to the power of 3, we'll multiply 2 over 3. I think there's a lot of repetition of 27 here, and even to this same power. So that's also how it looks. If you work well, you will discover that you would be solving most of the things that you will see in any exam that you're preparing. Just work with a lot of exercises. Now see what I'm going to do with 64 here. Remember we used 4 to the power of 3 earlier, but 4 to the power of 3 will not be that helpful for us here. Of course, we'll still get an answer, but it will take our time. So because I'm seeing 2 as a denominator of the power here, so I can just take this to anyone that will give me power 2, and it will make my work easier. So I can just write this as 8 to the power of 2, and that 2 will multiply minus half. So this is all over, then multiply by minus 2 over 5. And your work is done. So what happens? This will go, and this will go. So here will be 3 to the power of 2 multiplied by 8 to the power of minus 1 all over 2 to the power of minus 2. So we can just, okay, now we can try to put 8 in base 2 so that we can simplify it together with the denominator. So this will be Our 3 to the power of 2 is 9. So 8 to the power of minus 1 can be written as 2. Our 8 is 2 to the power of 3. And that 3 multiplying minus 1 will be minus 3. All over 2 to the power of minus 2. So here we can now work on these 2. So if we do that, we are going to have 9 times, now it will be 1 base 2, then the power is minus 3. So since it's division, you are going to have minus minus 2, and minus minus 2 is plus 2. So this will give us 9 multiplied by 2 to the power of minus 1, because minus 3 plus 2 is minus 1. So and that will give us 9 times, this is 1 over 2, which is 9 all over 2, and that is the solution there. So this is for problem 7. Okay, so we go to 8. Okay, so this one is beautiful. Just find the solution of this. Comment your answer in the comment section. All right. Okay, so we go to the next one, which is number 9. Okay, so here what do? You're expected to simplify what you have. First of all, we can do 2 things to this guy. Of course, there's a rule that says that anything to the power of 0 is 1. So we can use that approach and just remove it, because when it multiplies with this, the both of them will remain the same. Or we can just use multiplication rule and add this 0 to this 1 over 3. Okay, so anyone, that guy will definitely go. So we'll just try to simplify this. So remember that this will be 2 to power 3 multiplied by 1 over 3. Then this one will be 5 to the power of 2. And you are done. Nothing serious here. So we are still dealing with the simple examples. So this and this will go, and you have times 5, which will give you 10. Okay, so and this is exactly how exercises should go. They go from easy to intermediate and to maybe something more difficult. Okay, so the problem 10, we are asked to simplify 16a. Okay, so for problem 10, we have numbers will multiply numbers. So I can have 16 times 2 to give me 32. Then in the numerator, a squared will multiply a raised to the power minus 3. And that will be a to the power of 2 plus minus 3. Okay. Then I will now have b to the power of 3 multiplying b to the power of negative 1. That will be b power 3 plus negative 1. And that's all over. So that's all over 8a minus 2, then b. Of course, this b is to the power of minus 1. So here we are now going to have, now there will be division. Number will be divided by number, and similar alphabets will divide. So this is going to be 32. Anyway, let's simplify the numerator first. So this will be 32. Plus minus is minus. So a will now be to the power of minus 1. Okay, and then b will be to the power of 2. So this is going to give us 32 over 8 is 4. Then here we will have a to the power of minus 1 minus 2. Sorry, minus 1 minus minus 2, because division changes to minus. So it will be something of this nature. And of course, minus minus is plus. So, and this will be minus 1 plus 2, which will be 1, multiplied by b to the power of 2 minus 1, which will also be 1. And that will give us 4a b as the solution for this. All right, so and that takes us to the 11th problem. Okay, so that's number 8 and number 11. What will be your solution? Put your answer as a comment in this video. Okay, so let's go to number 12. Of course, this is a simple one to see. What do? Once it is an equation, remember what I said, try to put both sides in the same base. Okay, and we can write 25 in base 5, and that will be to the power of 3. That 3 will multiply the existing power, and that will be equal to, here will give us 1 all over 5 to the power of 2. But then remember, like we have always said, when you have 1 all over, you can change it to negative power. And so this will be 5 to the power of negative 2. So once the bases are the same, we can take them out, and that will give us the powers will now be the same. And 3 multiplying here, and you are done. Cross multiply. This, of course, you can first of all take away the minus sign on both sides. So if we cross multiply, this will now give us 2y is equal to 6 times 1 is going to be 6. And so dividing both sides by 2 will give our y as equal to 3. Okay, example, problem 14 is another one here from what I'm seeing that you're going to solve. It says we should evaluate. So I'm going to allow you to do this also and turn in your solution in the comment section below. Okay, so let's look at the next. Very beautiful. So I'll start by, once, remember, like I said, there is an equation. Try to put everything you have in the same base. And I can write all of this in base 3. So this is 3 to base 1 multiplied by, to power 1 multiplied by 9 is the same thing as 3 to the power of 2. And that 2 will multiply the existing power, which is equal to 3 to the power of 3, which will also multiply the existing power. All right, so and that's going to give me, so here I can try to open my brackets. So here I will have 2 plus 2x. All right, so this will now be applying the rule. So you just pick one base and add the powers. So this will be 1 plus all of this will give us 3 plus 2x as equal to 3 raised to the power of negative 3x. So since we have achieved what we want, we can now write 3 plus 2x is equal to negative 3x. Take like terms together. So 3x minus 3x coming here will become positive, and so 2x plus 3x will give us 5x equal to positive 3 crossing over here will become negative. Therefore, our x is negative 3 all over 5. Let's move on to the next one, which is 16. All right, so for 16, we are asked to simplify 0.027 to the power of negative 1 over 3. So how do you do that? It is also very simple. Whenever a decimal is given, always try to change it to a fraction. So of course, to change 0.027 to fraction, all you need to do is to write your 27 and then all over 1. Then you count the number of digits after the decimal point and you represent it with zeros. Okay, so since we have 3 digits here, so we represent it with 0, and that will be 1000. So everything now is raised to the power of minus 1 over 3. And what can we do with that? So we'll just try to see, can we put these numbers in index form? Yes, we can write 27 as 3 to the power of 3 all over 10. Amazingly, is the same thing. 1000 is also 10 to the power of 3. So everything is raised to the negative power of 1 over 3. And this is going to be, remember what I said about distributivity of power, so over division. So I can actually bring out the power 3 that is upon 3 and 10 this way. So and when I do, it will now multiply the already existing power, which is minus 1 over 3. Okay, and you are done. So this 3 here will cancel this, and then you just have 3 over 10 all raised to the power of minus 1. And I'll show you a trick. Of course, this is supposed to be 1 all over this fraction. And whenever you have 1 all over any fraction, that's reciprocal. Just turn that fraction upside down. So this is going to give us 10 all over 3 as the solution to this particular problem. So then we move to the next one, which is problem 17. We are given that 3 into 2 raised to the power of x minus 3 is equal to 384. And of course, we are to solve it. So to find the value of x, what do we do? Here, the best thing to do is to first of all clear this bracket. And if you clear the bracket by using 3 to multiply, it will not make sense because the base here is already 2 and is different from 3. So the best thing to do is to try to divide both sides by 3. And if you do that, this side will be 2 to the power of x minus 3 is equal to, here will now be 384 over 3. If 3 divides 3, you get 1. This is beautiful. So what do you get? Now you will check, can we write 128 in base 2? And the answer is yes. 128 in base 2 will give us 2 raised to the power of 7. Remember that 2 raised to the power of 5 is 32. To power 6 is 64. And so if you multiply again by 2, you will get 128. Okay? And you are done. This is x minus 3 is equal to 7. Therefore, our x alone will be 7 plus 3, which is equal to 10. Okay? And then we check number 18. Beautiful also. Here we are asked to, you are also looking for the value of x, okay? So it's an equation. Remember I called it exponential equation. So, and then you can check all the numbers in the base are all possible exponents of 2. So this is going to give us, this one is already in base 2. So we will try to write 64 in base 2, which I already said here is 2 to the power of 6. So that 6 will multiply the existing x to give us 6x divided by 8 is 2 to the power of 3. Okay, and so we'll have 2 to the power of 2x is equal to, here will be 2 to the power of 6x. Remember, division will change to subtraction of powers. So you just have minus 3x. And then, of course, the equal basis will go. So 2x, which is the power on the left-hand side, will be equal to 6x minus 3. So what do you think there? Collect like terms. Okay, so if I bring 6x this way, and this is going to be minus 4x is equal to minus 3. And therefore, of course, minus will cancel minus. If you divide both sides by 4, you will get 3 all over 4 as the value for x. Okay. So we move over to 19. Problem 19, we are moving. It says that we are to simplify what we have here and then get our answer in this form where p is between 1 and 10 and m is an integer. Okay, so this is just multiplication and division in standard form. But of course, you know, standard form is just an offshoot of indices, or what you can say is a baby indices. So what do you do here? You can split this into 2 this way. Let the numbers divide, then times, let the ones in power divide, okay? Or you can actually make this to become a whole number first, and then you now try to do the division, which is possible. Because I can bring out 110 here. I know that if I use 110 to multiply this 9.6, that will give me 96. And so only I've removed 110, so it's remaining 17. Okay, all over. Now to convert this one to whole number, I will need 2 tens, which is 100. and that will move this decimal point to the front. So that is 24. Then multiply by here, I will only now have 10 to the power of 3 because I've removed 2. And that is it. So you can now do the splitting I talked about here. So 96 will be divided by 24, and that's equal to 4. Because 24 times 2 is 48, and 48 times 2 again is 96. So you now bring multiplication, that's from here. Then you will now do this one, 10 to the power of 17 minus 3. And so your solution is 4 times 10 to the power of 15. So assuming that they asked you to get your P and your M, so it means that our P is 4 and our M is 15, okay? And that is for 19. So we move to number 20. Here we are to evaluate what we are given. So what do? Always, once there is a base, try to put it in index form and see what it gives you. So of course I can write 125 as 5 raised to power 3. I've said that before now. So this will be all over 3. Then plus, here I have 5 over 2. So I can still leave it this way. Power minus 2. And this is going to be 3 here will take away 3. So I have only 5 to the power of minus 2 plus. So at this point, I can choose to distribute the powers on these numbers, and that will give me 5 to the power of minus 2 all over 2 to the power of minus 2. Okay, what would that help me do, and why did I do that? Now this particular question is just like every other maths problem. You can use any and many kinds of approach. So I can choose to simplify what I have and then try to solve. That's by taking LCM. Or I can choose to bring out 5 raised to power minus 2 and then simplify the inside. So anyone. So if we choose to simplify, then I can remove the 1 over, that's all over 1. And if I do this, I'm going to get 1 over 5 raised to power 2, which is 25. And that is plus the, meanwhile, remember that this part, I can actually write it as 5 raised to power minus 2 divided by 2 raised to power minus 2. Okay, so and that is going to give me 1 over 25 plus, here would also be 1 over 25, then multiplied by, okay, before that multiplication, let's still retain our division here. So here will now be 1 all over 2 to power 2, which is 4, okay? So at that point now, we can try to bring this down, 1 over 25 plus, so here we'll have 1 over 25 as well, then times 4 over 1, okay? So which is going to give us, of course, this would clear the bracket first. This is 1 over 25 plus, this is going to be 4 over 25. And since the denominators are the same, you will just add the numerators. So you have 5, which is 1 plus 4, all over 25. And that's not a good place to stop, because you can reduce that into a smaller form that will give you 1 all over 5 as the solution of that big looking problem. All right, so if you had chosen to factorize 5 raised to power minus 5 raised to power minus 2 here, let's see which one would have been faster for us. So assuming we did that, we would have gotten 5 raised to power minus 2 into the bracket of this will be 1, then plus here you will have 1 over 2 raised to power minus 2. I think this is going to be faster, because here if you change this now to fraction, you will have 1 all over 5 raised to power 2, which is 25, into the bracket of 1 plus. Remember we said that whenever you have 1 over a negative index, you can actually write it as you change this to negative. So this is going to be 2 raised to the power of minus minus 2, which will now turn to plus. Okay, so which is going to be 1 over 25 into the bracket of 1 plus 4, which is 5. So this will now cancel out to give us 1 over 5. So I think that factorizing out will be a little bit faster for us, but either ways, anyone you choose is also okay. So we move over to 21. Okay, so we have to simplify this. So whenever you are asked to simplify, it's more like reduce the value of this. It looks big, make it smaller. Okay, so all right, so let's go on. What are we going to do here? We will, this is fractional index with negative value. So let me quickly teach us something here. Whenever, remember I mentioned it earlier, whenever you have a fraction like this and it's raised to the power of minus 1, this thing means reciprocal. That's 1 over this. And so you just take it as b over a. Now it is b over a because the power is 1. Ordinarily you should have raised it to power 1. So but we didn't do that because it will still be the same. Now what if the power is not 1 and you want to do this as fast as this? So let's assume that the power is n. So all you need to do is still use the minus power because you are assuming that this is the same thing as minus, look at it, a over b into minus 1 then times n. So still use this minus 1 to turn this around as b over a, and then you now raise it to power n alone. So all of this is to make your work faster so that you will be able to hit whether it's an exam or whatever you're doing at record time. So I can actually write this as 81 over 16 all raised to the power of 3 over 4. The minus will go. Then multiplied by, here is easy. Of course, square roots will come on both numerator and denominator, and the square root of 100 is 10. All over the square root of 81 is 9. Okay, so here, once you have a power like this, fractional index, I prefer that you take this to index form, okay? Because, of course, the other thing you would have done is to take the denominator here as a fourth root. For me, I know that the value of the fourth root of 81 and the fourth root of 16, but you may not know. So going with this approach will be far better for you. So you can write 81 as 3 to the power of 4 and 16 as 2 to the power of 4 as well. Okay, and this will give you 3 over 4 here multiplied by 9 over 10. 10 over 9. Okay, so here now you can gather this 4 up, and when you do, you just have 3 over 2. So when the 4 comes up here, it will multiply the existing power, which is 3 over 4, and then you have times 10 over 9. Okay, so, and you are done. So 4 here will take away this 4. So you just have 3, let me finish that here. So you just have 3 over 2 raised to the power of 3. Okay, so you can return back our power. So 3 raised to the power of 3 will be 27. All over 2 raised to the power of 3 will be 8. And this is multiplied by 10 over 9. So you can see something can cancel out here. Of course, 9 here is 1 and 9 here is 3. So 2 here is 4 and 2 here is 5. So we multiply out. 3 times 5 is 15 all over 4. And that is our solution for 21. Go to 22 straight away. So what are we asked to do there? What do? Change both sides to the same base. So I can write this as 3 to the power of 3 multiplying 1 plus x equal to this side as 3 to the power of 2. So which means I can remove the equal bases, and so I will now have 3 into 1 is 3 plus 3 into x is 3x equal to, on this side you just have 2, which is going to give us 3x alone, collecting like terms. This coming over here will be minus 3, and that will give us minus 1. Therefore, dividing both sides by 3, we have that our x is minus 1 all over 3. Okay? And that's for 22. We are close. So 23 is asking us to do 27 raised to the power of minus 1 over 3. And again, I'm going to leave this for you. It is, of course, very easy to see. We have been doing problems like that. So we go to 24. So what is this going to give us? This is very beautiful, okay? What do we do? Gradually, so we start with division of numbers, alphabets, and similar alphabets. Let's still leave this one as square root, okay? Or we can actually change square root to power half. You know that square root means power half. Okay, so let's leave it there. Now, what can divide here? 5 can go here to give us 25. All over 5 can go into 45 to give us 9. Okay, let's use multiplication, and then we go to A. A is going to be A to the power of 5 minus 3, which will be 2. Then we multiply again by B. Okay, so B will be to the power of minus 2 minus 2 again, and that will give us minus 4. Okay. So this is going to become, recall that 25 is the same as 5 to the power of 2, and 9 is the same as 5 to the power of 2 also. Is 3 to the power of 2. Okay, so here I can now write this as 2a and then 4 to the power, b to the power of negative 4, all raised to the power of half. Now remember what I said about the distributivity of power on multiplication. So this half is going to come in and multiply all the powers here, because this is division and this one is multiplication. So if half multiplies the power of 5, it will cancel it and give you only 5. All over, it will multiply the power of 3 and give you only 3. To multiply the power of A and give you only A. To multiply the power of B and give us minus 2. All right, and so this is a good place to stop, or you can choose to write it this way: 5ab minus 2 all over 3. Or another person may choose to bring down this b here, so you have 5a all over. The reason you are bringing it down is because the power is negative, so if it comes down, it will change to positive, so you have 3b squared. So any of these three forms is just one and the same thing, and that's the solution to that 24. Okay, so we are already at 25, and 25 says if, 3 to the power of 1 minus n all over this is equal to this, you should find the value of n. Here again, everything can be written in base 3, so you try to do that. This one is already in base 3, so the denominator I will write as 3 to the power of 2, and the 2 will multiply the already existing minus 2n, and that will give me minus 4n is equal to, this one is 1 all over 3 to the power of 2, so but I already have 1 over here, so I can write it as minus 2. So you see now I am jumping some steps because I believe you have mastered what we are doing. That's what doing many exercises, that's what it does for you. So here division will change to subtraction. So I'll have 1 minus n, then minus 4. And minus 4 will turn to plus 4. That's equal to 3 to the power of minus 2. And immediately equal powers will go. So equal bases will go. So I just have 1 minus n plus n will give us 3n is equal to minus 2. Take over 1 to this side. We'll have 3n alone is minus 2 minus 1, which is minus 3. And this is equal to, our n will be minus 3 over 3, which is minus 1 as our solution. This is very beautiful as well. So number 26. Okay, number 26. Okay, sorry, that thing is the last operation here is not multiplication, is division. Okay, so here again I have something that looks like the exercises I've been giving you, so and I would like you to also do this one. So of course it's very straightforward. 625 to the power of 3 over 8 times 5 to the power of 1 over 2 divided by 25. Everything here can be expressed in base 5, so you should be able to do that. So permit me to go to the next one, which is 27. Whenever you have a mixed fraction as your power or a decimal, always change it to normal fraction, whether improper or whatever. So this is going to give us 1 over 4, all raised to the power of, this will be minus 3 over 2. Okay, so what can we do with that? Clearly you can see, you can turn these two to square roots, and that will help you since we can easily evaluate the square root of this. So this will be square root of 1 over 4, all raised to the power of minus 3. And this is going to be, what is square root of 1 is 1. What is square root of 4 is 2. So everything is raised to the power of minus 3. Now remember what I said earlier, that whenever you have a negative power, it will always help you if you take this approach. If what the negative power is on top is a fraction, just turn the fraction and remove the minus sign. So if I turn this, I'm going to get 2 over 1, which is 2. And then the power will no longer be negative. It will now be just 3. And that will just give me 8. Straight away, you get your solution. So of course, you can choose to do it the religious way, but you won't only be wasting time. So what I mean by that is that I have 1 over 2 raised to the power of minus 3. So this is going to be 1 all over 1 over 2 raised to the power of 3. So which will give me 1 all over, so this power will distribute, which will give you 1 over 8. And then of course this will turn over to be 8 over 1, which is still 8. So you will just save yourself the stress of writing many steps if you can always find time to use some of these approaches. And yes, we are almost done. So let's go to number 28. Okay, yes, again, I've given you problems like this before, so I'm also not going to do this one. It's very obvious. Yeah, you can take this one to base 2 and take this, or take this to base 8, since this is already in base 8, and then you can simplify these two and then join whatever you have with this one. So let me leave that there. Okay, so let's go to 29. Okay, so here we are to solve this equation, and you know, to solve an equation, like I will always say, is to find the value of x. So what will happen here? We will try to write everything in base 3. So of course I can write this as 1 all over 81 is 3 to the power of 4, and that 4 will multiply the bracket. Remember, like I said, as we keep solving, you can start jumping some steps. So I can immediately open the bracket and I'll get 4x minus 8. And then that's equal to, here will be 3 to the power of 3. We'll multiply this, which is 3 minus 3x. Okay? And then immediately, my 1 all over means negative power. So I'll have 3 raised to the power of, minus will multiply this to give me minus 4x. And it will multiply this to give me plus 8. Everything is now equal to 3 raised to the power of 3 minus 3x. So here is me just teaching you how you can jump some steps. For instance, if I was the one doing this, maybe an exam, I can actually move from here straight to this point. You know, I can move from here to here immediately, all right, without wasting the time of writing this step. So that's exactly what many problem solving will bring you to. Okay, so it is not about that this person is a teacher. No, it's about the commitment to solving problems. You will get to know how to do it, and then you will jump by like 2 steps ahead. That's what people call trick, or what they call shortcuts. Okay, So this is now going to give us equal basis. We have gotten equal basis, so our powers minus 4x plus 8 will be equal to 3 minus 3x. Okay, we can bring x to one side and the other one. So here we would have minus 4x, minus 3x coming over will become positive. So we have minus 4x plus 3x, which is minus x is equal to 3 will be here. 8 coming over here will be minus 8. So 3 minus 8 will be minus 5. Therefore, our x is simply equal to 5. How did we get that? Minus signs will cancel out, and that is your solution. Oh, hooray, we are in the last problem, number 30. Wow, what a journey we've had. Okay, number 30 now happens to be 2 in number. So they said we should solve the following, and so they gave us the first one. They said is 4 to the power of x equal to 0.5. This is very simple. So what are we going to do here? We remember I said once there is a decimal number, change it to fraction. And so this is 1 over 2. Okay, so we take everything here to base 2, which is possible. So we can write this as 2 to the power of 2, and that 2 will multiply x to give us 2x equal to, on this side we will have 2 raised to the power of minus 1. Okay, equal basis will go, so we have 2x is equal to minus 1, and therefore our x alone, you divide both sides by 2, you get minus 1 over 2. Okay, ladies and gentlemen, the second part I am going to leave as an exercise because it's an equation, and I think that's the only equation I am giving you. The rest I have given you evaluation. So this is 9 raised to the power of x is equal to 1 all over 729. Of course, to solve means you should find the value of x. And that is the end of this first exercise that we started with 30 questions in one exercise. Okay, 30 questions. And I expect that when you are done with this, you can even choose to, lock up your video, write out these exercises and go through them on your own and see if you would get the same solutions. Alright, so this is where we end it for this video. Kindly subscribe to our YouTube channel. Do take care of yourself, and I would like to see you in any of my other videos. Bye.